Hi, Algebra 2. We have two learning targets today. The learning targets is I can simplify exponents and I can convert between radical and exponential notation. So first we need to remember our rules of exponents from Algebra 1. And the first one is here with anything to the 0 power is equal to 1. So another example would be 2x to the 0 power, then that would also equal to 1. But a different example would be if it was 2 times x to the 0 power, only the x to the 0 power becomes 1, so that would be 2 times 1, which would equal to 2. So notice the difference that this entire item is to the 0 power, where here just the x was to the 0 power. Our second rule to remember is our rule when we have a negative exponent. Remember, anytime that is the case, you're going to move something. So you're going to move whatever is to that negative exponent down or up, depending on where it is, and then you lose that sign. So let's say we had 1 over 5 to the negative 2. Then that would equal, first you would move it, so this 5 to the negative 2, we move it up to the numerator, and that would be 5 squared, because every time you move it, you would move it either from the denominator to the numerator or the numerator to the denominator. And once you move it, you lose the negative sign. So in this case, there's nothing left in the denominator, so it would just be 5 squared, which would be equal to 25. Our third rule is when you have the same base, remember you add, and we've been doing this one all year. So remember, when you have the same base, so a to the m power times a to the n power, you're going to be adding your exponents. And this one you've seen a lot. We've been talking about x to the third times x to the squared. You would add these exponents, so that would be x to the fifth. So here you're adding the same base. When you're multiplying the same base, you add the exponents. This one you haven't seen as much, but you probably remember from Algebra 1, when you have the same base and you're dividing, then you subtract the exponents. And I think we've done this a little bit, but let's say you had x to the third divided by x squared. It would be 3 minus 2, so it would be equal to x. Because 3 minus 2 is 1, so x to the 1 power. Our next rule is when it's to a power. So here you're going to be multiplying. So let's say it was x to the fourth to the second power. We multiply the 4 times the 2, so that would be 8. So our answer would simplify to x to the 8th power. So here it's showing that it's multiplication when it's a power to the power. Our next one here is when the whole thing is to a power. You distribute the power to each item. So an example, let's say we had x, y, or let's say 2xy to the third power. Then it would be 2 cubed, because 2 to the third power, and then x to the third power, and then y to the third power. X cubed and y cubed are as simple as they can be, but 2 to the third power we can simplify to 8. So your final answer would be 8x cubed, y cubed. And the same thing occurs when you have a fraction to the power. So here you have a divided by b to the nth power. So that would be a to the nth divided by b to the nth. So let's say we had 1 over 4 to the second power. Then that would be equal to 1 squared divided by 4 squared. 1 squared is equal to 1, and 4 squared is equal to 16. So your final answer would be 1 over 16. Now here's the ones with radicals. We've been talking about these a little bit, how we could split up the radical. So our index here, you can, if it's multiplication inside your radicand, you can break out your radical. So the nth root of AB could be equal to the nth root of A times the nth root of B. And we did these when we had negatives. Remember our unit where we had like negative 16? How we broke that into the square root of negative 1 times square root of 16. Remember that was the same index here. And we simplified, remember the square root of negative 1 is I, and the square root of 16 is 4. So then we use this exponent law to help us simplify, and that would simplify to 4i. We can do this in any case, and we've been doing that some with our simplifying our radicals. This last one here, we just started to touch on it. When we have a fraction of the same root, you can also simplify that fraction and have the nth root of A divided by the nth root of B. So in our problem that we didn't get to last class in our notes, where you had the square root of 9 over 8, it was not 8 over 9, it was the square root of 9 over 8, you can simplify that to square root of 9 over the square root of 8. And then we would want to rationalize our denominator, not have the radical in the denominator, so then we would multiply by the square root of 8 over square root of 8, so that we would not have the radical in the denominator. Then that would become the square root of 72 over the square root of 64. Our denominator simplifies to 8. Our square root of 64 is 8, our perfect square. And then if you wanted to pause for a minute and simplify the square root of 72, go ahead and do that and bring it back. Okay, so depending on when you saw your pairs of 6's, you might have simplified further, but as soon as I saw my 36 simplified to 6 times 6 times 2, I went ahead and simplified my radical. So I pulled out my pair of 6's, and I had 6 square root 2 over 8. Now I'm noticing there's a factor of 2 in both items. So I'd keep simplifying, and we'd break out 2 times 3 for 6, and 2 times 4 for 8. And this radical would simplify all the way to 3 square root 2 over 4. And we were just using this property when we do that throughout to simplify our radical. And again, this is what's more simplified, this right here, which I'm not sure which one looks more simplified to me, but this is the rules we have to follow. Okay, if you turn over on the back, we're just going to try a couple problems. And the first one, number 1, we have all these fractions, so don't get thrown off by the fractions. We're still going to add our exponents here because we're all multiplying. And luckily for this first problem, when we go to add, our denominators for our fractions are the same. So we can just add all our fractions. So we have x, same base, and our fractions we would have to have the same denominator. So the 2/5 plus 4/5 plus 3/5. Here we would have 2 plus 4 plus 3, which would be 9. So we have x to the 9/5. That would be our final answer. For our problem number 2, we have the same bases being subtracted, plus our fractions are the same. So in both of these, we're going to be subtracting our exponents. So we have our negative 3/2 minus a 1/2. So our x's are the same base, so that's why I'm subtracting these two. So x to the negative 3/2 minus our divided by our x to the 1/2. So we subtract those exponents, minus 1/2. And for y, we have y to the 2/3 and y to the negative 1/3. That's dividing y to the 2/3, so we'll subtract here as well. So we have y to the 2/3 minus a negative 1/3. So we have negative 3/2 minus 1/2 would be negative 4/2. And we have 2/3 plus 1/3. So that would be 3/3. So now we're going to simplify our exponents. So negative 4 over 2 simplifies to negative 2. So we have x to the negative 2. And y to 3 over 3 simplifies to 1. So our last step here is we still have a negative exponent. We can't leave any negative exponents. So now we're going to use that rule. And that means we'll have to move it to the denominator. So our y stays in the numerator. Our x to the negative 2 moves down, and then we lose the negative sign once we've moved it. So our final answer is y divided by x squared. Okay, I'm going to skip number 3 just to save time, so I had more time to talk about the second learning target. Just know that 3 was just talking about the power to the power. So you'd every item inside would be to the 3/4 power, and then you'd multiply your exponents. But again, I want to spend a few more minutes on the second learning target, so we'll be practicing a lot of exponents in class. But first I want you to think about converting between the two. So the first thing you want to be looking at when we have our radicals, remember that our item, we can rewrite this as the index is still 5 and then x to the 3rd power. So this is all to the 3rd power. So when you're converting between radical and exponential, you always put the exponent over the index. So that's the first thing to realize. So the exponent over the index. So we have our inside number over our outside. Let me fix that. And so when I was converting, our exponent here is the 3. So that's our numerator. And then the 5 is the index. So that would be 3 over 5. Another way to remember is that this 5 is like in a ditch, so it goes in the denominator. So we have the inside part over our little ditch here. So exponent over index, inside over outside, whatever helps you remember, that's going to go into the denominator when you're converting between the two. So first I'm going to change it over so you can see that this is x to the 3rd to the 7th, and then I'm going to do my exponent over index. It stays in the denominator. That's where the radical was, so we have the 3 over the 7. Okay, in reverse, the same thing is going to occur, but the denominator becomes the index. So that goes into our little ditch, if you will. And then the exponent goes inside. So we have our exponent over our index, or the denominator goes into our ditch here, our index. Our last one here, number 4, has a negative sign, so I have to move that first, and then